Well, hello, class. We're going to look at this podcast today. We're beginning unit number 3. So you'll need to get out your composition notebook that we made in class. And what you want to do is you want to open it up, find you a clean page on the right-hand side. You want to write down unit 3, chemical reactions. And then you want to flip it over and you want to begin your numbering. Again, number 1's on the left. Number 2 is on the right. And then flip it over. 3 is on the left. 4 is on the right, and continue numbering through your composition notebook. And you should have your outline that you did and I gave to you in class, and you should work on those notes out of the textbook on the odd pages. And then what we're going to go through today are the notes that you'll want to write these things down on the even pages. And then I'll see you in class, and we're going to talk more about this. We're going to work some worksheets. We're going to do some labs and some other things. So Unit 3 is all about chemical reactions. So on page 1 and 2 of your composition notebook, if you haven't done what's on page 1 yet, what you want to do is pause this video, go ahead and complete that, and then come back to this video. All right, first thing I want you to understand is what we call word equations. Now, when we have chemical equations represent chemical reactions. And so a word equation is a chemical reaction that's written with the names of the compounds. And we must take the word equation and we must be able to change those names to formulas. And then therefore, when we change the name of the compounds to formulas along with some symbols, we have what we call the formula equation. So in the last unit, we dealt with naming and writing chemical formulas. So here we have to be able to do that as well, and we're putting this together. All right, a couple things you want to jot this down. So you want to pause the video at this point and jot these state symbols down. All right, after pausing the video, you want to restart this. And when we have these state symbols, these are written beside the chemical formulas. I'll show you plenty of examples with this. And we put them in parentheses, written like a subscript right beside the chemical formula. So S stands for something that is a solid, so these do not dissolve. G would be a gas. They also, of course, would not dissolve. L would be a liquid, so at normal room temperature, standard temperature and pressure, we call it, these are liquids. And then AQ stands for aqueous. And what that means is that it's dissolved in solution. Usually that solution is going to be in water because a lot of chemical reactions happen in water. Now, we also have this. You'll be given a copy of a solubility table that will be something like this one. And what this shows you is that when you have certain compounds, which ones are going to be solids, which ones are going to be aqueous. If it says solid, it means it does not dissolve in water. If it says aqueous, that means it dissolves in water. So, for example, if you look at this, if you have like aluminum acetate, so here's your positive ions, here are your negative ions. So aluminum acetate, you just find the grid, and that has an S. So S stands for solid, so aluminum acetate does not dissolve in water. However, right beside it, you have aluminum bromide. So if you have that compound and you put it in water, it says AQ. AQ stands for aqueous. So that means it dissolves in water. And I'm going to give you a chart that'll be similar to this in class that you can use for your chemical reactions. And also, I'll give you some solubility rules, and you'll need to know those solubility rules as well. All right, what I want you to do at this point is pause the video for just a few moments. Jot down this example of a word equation. I'm going to show you how we take the word equation and we put it into a formula equation. So go ahead and pause the video at this time, and we'll do this. All right, so after pausing the video and copying down this word equation, we have solid calcium carbonate is heated and produces solid calcium oxide and carbon dioxide gas. So it's important that you have all this down. All right, so let's flip over and we'll do this one in your notebook. So solid calcium carbonate. So the first thing we need to be able to do is write the correct chemical formula. So here's example number 1. And we have calcium is Ca. We look up its charge is 2+. And then carbonate is a polyatomic ion, so it's CO3, 2 negative. And you can use your polyion table here as well. And some of you, I'm asking you to memorize these in class, so the ones that you need to know. Now, then what we want to do is go ahead and write the correct chemical formula for that. And so we have CaO. So don't forget about what you were supposed to have learned in the last unit. If you forgot that, go back, relearn that, or learn it again for the first time, whatever it takes. Now it says this is solid. So what we want to do is we want to put in parentheses a little S right there. So this is solid calcium carbonate. And then it says it is heated and produces. When you see something that says heated, you're going to put you're going to put the arrow right here. And so that means produces, or sometimes we say yields. And so what does it produce? It produces solid calcium oxide. So calcium oxide, we're going to put Ca2 plus. We're going to put O for oxide, 2 negative. So that again is a 1-to-1 ratio. So we have CO, and it is a solid. So we put a little S right here. And something else as well. It says and carbon dioxide gas. So we say plus. Now remember, carbon dioxide would be a molecular compound, so we use the prefixes. So we have CO, and there's only one carbon, and it says dioxide, so that's 2. And this is a gas, so we put in parentheses a little G right beside it. And basically that's it. Sometimes we add other symbols. For example, since this one's heated, we might add a delta symbol right here. That's a little triangle. And when we put that above it, that means that it is heated, okay? So just sometimes you'll see symbols like that. But that was basically it for that one. So now let's go to our second example. And you'll want to pause the video at this point as well. And you'll want to copy this example down in your notebook. Okay, after pausing the video, we're going to write the formulas for this one. It says aqueous silver nitrate reacts with aqueous sodium chromate to produce solid silver chromate and aqueous silver nitrate. All right, go back to your notebook paper and let's write down the formulas for this one. So you've got the word equation written right above it, and now I'm going to show you how to take the words and put it into the formulas. So we have silver nitrate. So silver is Ag. Now, I'd probably give you silver 1, but one of the things that you need to know is silver is always positive 1. So just try to remember that. So we can put a 1 plus there, or just a plus. And then we have nitrate, so that's NO3, and that's 1 negative. So we have AgNO3 for your formula there, okay? And then it says, or it reacts with aqueous sodium chromate. So sodium is Na, it's a group 1 element, so it's positive charge. Chromate is CrO4, and it is a 2 negative charge. So we're going to write plus because it reacts with, and we're going to write Na2CrO4. All right, then it says to produce. When you see that to produce or makes or forms, you're going to put the arrow right there. Solid silver chromate. So, oh, wait a minute. I forgot to go back. Or I forgot to write the state symbol. So let me go back. It says this was aqueous, so we need to put the AQ there. Okay, almost forgot that. And it says that this one was aqueous as well, so we should put the AQ there as well. So I have to kind of squeeze that one in. It should go right before the arrow, but I almost forgot to do that. All right, then it says it forms solid silver chromate. So silver, again, is Ag plus 1. Chromate is CrO4, 2 negative. So this is going to need to be Ag2CrO4. And this says it's a solid, so we're going to put a little S right here. And it also produces aqueous sodium nitrate. So we'll put a plus sign, because we say and, just like in math, we put a plus sign. And then it has sodium nitrate. So Na plus 1. Always check your charges, and I usually do this, right above it, or you could do it below it, or whatever works. But I do it right below it. So sodium nitrate, NO3, 1 negative. And so we have NaNO3, and then we're going to put aqueous, okay? Now notice the subscripts do not come over. When these chemical reactions happen, all the elements and atoms get rearranged, okay? It's sort of like taking a deck of cards. If you play cards and you're ready to deal a new hand, you put all the cards together and you reshuffle the cards. And so when a chemical reaction happens, atoms are actually reshuffled and formed into new things. All right, so let's go to our example number 3 now. Pause the video at this point and copy this example down. Okay, in this one we have propane. I went ahead and gave you the formula for propane. It's heated in the presence of oxygen and forms carbon dioxide vapor. All right, so let's take a look at this one, and we will convert this one over to words as well. So this is number 3. So propane, I've already told you the formula for that. So we were just writing down C3H8 because I've told you the formula for that. It says it is heated in the presence of oxygen. So that means it reacts with oxygen. Now, oxygen gas is what we call diatomic molecule. So oxygen is always O2. All right. Anytime you have oxygen present by itself, it's just oxygen gas, then it's O2. And by the way, it tells me this is propane gas. So this is G and for the gas, and we have to have a little G here for oxygen gas. And then what does it form? Well, it forms, so we put an arrow, carbon dioxide gas, CO2 with a G, and then also it forms water vapor. So we're going to put H2O, and we're going to put a little G right here for water vapor. Now, we haven't balanced these yet. We'll go back and we'll take a look at balancing a little bit later on. And but that's how you take the word equations and you convert it into the formula equations. All right.